In this experiment, the shell and tube heat exchanger at various operating conditions experiment aim to evaluate and study its performance from several of its criteria that includes mass flow rate of hot oil and cool water, heat balance, log mean temperature difference, overall heat transfer coefficient, NTU, and effectiveness for counter-current flow. This experiment is focusing on counter flow, which will have the fluid of different temperature flowing against each other in opposite direction to transfer heat. This indicates that the reading will be taken every 5 seconds and the water flow rate will be modified. The inlet temperature of the hot oil was adjusted to be 60 degree, 65 degrees Celsius, 70 degrees Celsius, and 75 degrees Celsius. When inlet temperature and outlet temperature of hot water increase, the mass flow rate also increases. The heat exchanger values for the 60 degrees Celsius, 65 degrees Celsius, 70 degrees Celsius, and 75 degrees Celsius were 4.55 kilowatt, 2.7 kilowatt, 1.96 kilowatt, and 3.68 kilowatt respectively. When we conducting our experiment, there might have some error that occur when we conduct the experiment that may affect our result and finding of our experiment. This might be caused by some error while we running the experiment. To acquire a more accurate reading for the experiment result, some precautions might have to be taken into account. The time taken for 5 seconds should take accurately by using stopwatch. Besides, the team member that control the water outlet valve also should be always alert to the time taken to avoid error occur that might affect the result. In conclusion, our group have achieved our objective in the experiment as we were able to identify various components and working principle of the process control system. Besides, we have learned to observe the relationship between the adjustment in the desired value of temperature and how the process variable reacts. We are also able to assess the heat transfer capabilities of the tubular heat exchanger by measuring the temperature profile before and after passing through the heat exchanger. That's all from our group. Thank you.